All right. Good morning, everyone, and welcome to the What's New in ONAP Dublin webinar. I have muted everyone upon entry, and why don't we get through the slides first, and then if anybody has a question, just feel free to unmute yourself and ask the question. My name is Amar Kapadia, and I'm one of the co-founders of Arna Networks. I'm also the author of a book titled ONAP Demystified. My background is in NFV and a bunch of cloud technologies such as OpenStack, Ceph, and data plane acceleration technologies. We are going to cover 4 topics today. We are going to do a quick overview of ONAP. There's different levels of understanding of ONAP. Some people are experts, and some people are really trying to figure out what ONAP is. So we'll do a quick overview. This is not meant to be an ONAP overview presentation, but we'll see a couple of slides. Then we'll go through some quick facts about the release itself, release highlights, and then finally we'll look at what's next. Okay, so ONAP introduction. What is ONAP? If you look at the HC NFV architecture, that's a good starting point for understanding what ONAP is. But as you will see, ONAP goes beyond the HC definition of a standard management and orchestration or MANO software stack. So in this picture, what you see is on the lower left, you see the NFVI, you see the physical infrastructure, compute, storage, and network. And then on top of that, you see the virtual infrastructure. So hypervisor or container layer, virtual storage, virtual networking, / overlay networking. On top of that are the VNFs, and they may have an optional element management system that goes along with it. So that makes up your data plane. On the right-hand side is the control and management plane. First you have the Vim or the cloud software, such as OpenStack or Kubernetes, that is managing the NFVI. On top of that, you have NFV orchestrator and VNF manager software. So typically when people say MANO, that's what they mean. They mean NFV orchestrator and VNF managers, and these two are doing initial orchestration and lifecycle management of network services and the underlying virtual network functions that make up those network services. But there are some additional components, and that's why we call this modified architecture. So on the right-hand side, you see 3 components. You see a design studio that is used to onboard VNFs, create network services, etc. A service assurance framework, without which you don't really have a viable NFV environment. You can call it automation, you can call it FCAPS, but the idea is the ability of the system to react to any fault, performance, or any other issues. And then most network services are not just NFV. They incorporate a healthy amount of SDN as well. And for that reason, the architecture needs an SDN controller, whether it's to configure WAN connectivity between clouds or within a data center / cloud. So ONAP covers the box in red, and it's sort of not a rectangle, it's kind of an odd shape. But what you see is it covers the standard HC MANO definition in terms of NFVO and VNFM, and it also includes a design studio, service assurance framework, and an SDN controller. So this is the ONAP SDN controller is mostly used for connecting regions, so WAN, and the expectation is that there's a separate SDN controller for the data center itself. So that's ONAP in a nutshell. This is the official ONAP diagram. And what you see, this is for the Dublin release as of May of 2019. And again, I don't have any intention of going through this. We simply don't have enough time. But what's interesting to note is that there are three main components here. There's the design time on the far left, where the main component is service design and creation, SDC. And you can do a variety of things through SDC. You can onboard VNFs and PNFs, and the shorthand for that is XNF. That's PNF and VNFs, and actually moving forward, it'll include CNFs as well. You can design services. You can design workflows of all sorts, controller design studio, DCAE design studio for creating closed loops. So that's all on the design side. And ONAP makes a great job of this delineation so that designers can do their tasks without having to rely on runtime. So there's a clean delineation. And on the runtime, the main projects are SO, or Service Orchestrator, that is used to orchestrate a network service. Then you have 4 controllers underneath the SO that SO takes advantage of for sort of more granular scheduling, lifecycle management, configuration, where the 4 are application controller for layer 4 through 7, sort of VNF, lifecycle management and configuration, SDNC, SDN controller, we talked about that, VFC, which is actually also an NFV orchestrator, and that's mostly used to talk to TOSCA compliant external SVNFMs and EMS systems. And then you have the multi-VIM/multi-cloud to talk to different types of clouds. On the service assurance side, the main components are DCAE. So all events, logs, metrics, alarms, etc., go into DCAE. DCAE crunches through it using a set of analytics microservices. Those events are sent to the policy framework. Policy makes judgment based on the policies it has, and then instructs the SO or one of the 4 controllers to take appropriate action. And then one last important project is ANAI, Active and Available Inventory. That's the inventory service. That is the single source of truth. It has knowledge of all active and available inventory, as the name suggests. Top, you have the APIs, and then the third major block, so design time, runtime, and manage ONAP. So ONAP itself is a cloud-native application that needs some other software to manage its lifecycle. And that's called ONAP Operations Manager, or OOM. Below, so on top of ONAP, you have OSS, BSS, and other applications, business applications. And below ONAP, southbound interfaces, you have third-party controllers like SVNFM and EMS. We talked about that. That's primarily through VFC. But increasingly, SO can talk to them as well. You have the network function layer in terms of VNFs and PNFs, and then hypervisors. So OpenStack, commercial OpenStack VIMs, Kubernetes, public clouds, etc. And we'll look at this in some level of detail. There are some shared services, some shared utilities, and that's about as deep as we're going to get into ONAP for now. There are many resources. We'll point out some of them if you want to learn more about what ONAP is. So now let's jump into the Dublin release. The Dublin release is the 4th ONAP release. The first release was in end of 2017. It was codenamed Amsterdam. So Amsterdam, Beijing, Casablanca, and now Dublin. Releases this month, July 2019. Number of commits, 16.2. 480 developers across 36 organizations. So this is a very healthy project, a very vibrant, dynamic, and healthy project. When you have 480 developers across 36 organizations, you know there's some real interest and activity in this project. And on the right-hand side, you see some of the statistics of this release. AT&T continues to be the #1 contributor. They, of course, were one of the founders of ONAP by contributing their ecomp code base. And then you see a number of pretty large contributors following them. For example, Ericsson, Huawei, Samsung, Nokia, IBM, Amdocs, ZTE, China Mobile, Intel, Bell Canada, Linux Foundation, Orange, etc. So there are multiple things this tells us. So first, it tells us that there's a healthy mix of users and vendors, which is very important for an open source project. And what this means is that the end user requirements are automatically flowing in to the project. So it's not like a bunch of contributors and developers will create something and then nobody will want it. It's the users are heavily engaged. The second thing you see is that the contributors span across the globe, right? You have them in North America, you have them in Europe, you have them in China, Asia, India, all over the place. So that again tells you that it's a very healthy project that's likely to be able to sustain, inevitably when times are not good, there's enough health in the project to be able to sustain those types of issues. So as you can tell, I'm pretty positive on the project, and let's keep going. There's a ton of commercial activity. Of course, this is not on Dublin. Dublin just got released, so prior to the Dublin cycle. And I'm not going to read this. This is from onap.org. You can go read this yourself. My goal is to be a technical presentation, so we are not really going to go through commercial activity. But suffice to say that, again, this level of commercial activity also suggests that this is a very successful project to date and has a lot of promise moving forward. So, okay, now let's get into the meat of the presentation, which is what we had intended to do. So what are the highlights of the release? There are 4 key things. ONAP has a concept of use case blueprints. And these use case blueprints are for a very specific use case. User and vendors come together, users and vendors come together, and they create this end-to-end POC/demo. And these are very important because they serve 2 purposes. One, they let other users know what is actually possible with ONAP. They see something concrete that they can recreate in their own lab. Second, it provides contributors feedback on what features they should be prioritizing. So we'll talk about a new broadband service blueprint, and we'll talk about progress on 5G and CCVPN prior blueprints, and then additional blueprints as well. So we'll look at that. And you'll see the words blueprint and use case used interchangeably. I prefer to use blueprints because use case suggests that ONAP can only do like 5 or 6 use cases, which is not true. ONAP, within reason, can serve any NFV SDN use case. The next is, progress around Interop and standards. So we'll talk about that. We'll talk about the new features, and then we'll talk about last non-functional enhancements, which are around security, stability, scalability, performance, etc. So let's jump in. So let's look at the blueprints. With Dublin, there's a brand new blueprint. It's called BBS, or Broadband Service. We'll look into it a little bit more detail, but it's a multi-gigabit residential connectivity over PON. ONAP is used for orchestration and lifecycle management of the service. And one of the key features in BBS is to be able to support a change of location of the CPE or the ONT. So that's sort of called nomadic feature support, where if the CPE moves, there's no human being involved. The system automatically, the service assurance framework automatically detects that, lets the orchestration side of the house know, and all appropriate changes are made automatically. So this, as you can imagine, is a huge cost savings in addition to the initial orchestration, of course, and lifecycle management. The 5G blueprint is a multi-release blueprint. So it's not complete in Dublin, but it's made tremendous strides as compared to what was there in Casablanca. And in the next 1 or 2 releases, it should have all the required support for 5G. So in this release, there's better configuration and PNF support, including the ability to upgrade the PNF. And of course, in 5G, the PNF physical network function support is important because some of the radio elements are not expected to become virtual. There's improvements in performance management and fault management, data collection, and there's modeling progress to ultimately support network slicing. So that's one thing that's not quite there, network slicing in Dublin. But as I said, in the next couple of releases, it should be fully supported. CCVPN is cross-layer, cross-domain VPN. It's essentially network as a service. It's an enterprise service. It's a pretty cool service. It was rolled out in Casablanca, and it showed peering of ONAP between China Mobile and Vodafone. And you could get an end-to-end service across the optical network and then between WAN, between service providers. So this CCVPN blueprint has been enhanced. You can now do dynamic addition of services. So you need an additional VPN, virtual firewall, you can drop it in. You need some AI ML service, you can drop it in. You can add branches dynamically. You can change the service, for example, bandwidth on demand. So a lot of very important changes to CCVPN, enhancements, I should say, to CCVPN. And then there are 2 other prior blueprints, VCP and VoLTE, that were supported in previous releases. So a little bit more about BBS. So as I said, the name is Broadband Service. And what you see on the left-hand side is customers, each with a CPE. So they have the ONT on site, and that's connecting to a multi-gigabit PON network. And what you see is the initial orchestration of the service, along with setting up the BNG, et cetera. All of that is done by ONAP. And then the re-registration. So initial registration of the CPE is also done by ONAP. So the first time the CPE is turned on, the entire service is provisioned. And then when the subscriber moves residences, which is often the case, then the re-registration is also automatic. There's a complete solution brief on BBS. So again, I'm not going to go into more detail here. We don't have enough time. But I encourage you to go read it. It's quite clever in terms of how they've done the re-registration of the CPE when the subscriber moves. We are not going to go into more detail on CCVPN and 5G enhancements, but what we're going to cover on this slide is, in addition to those sort of major blueprints, there are also additional blueprints in the works. So there's a blueprint to support Kubernetes as a cloud region, and they had their first set of functionality that rolled out in Dublin. So Dublin is able to now support container-based network functions through multi-cloud. So that's, I would say, the very first support for CNFs in ONAP. Of course, more work needs to be done, but this is an important milestone. Now ONAP officially supports CNFs, VNFs, and PNFs. Control loop requirements. There's a number of enhancements to make the control loop more model-driven so it's easier to set them up. Common notifications across orchestrators and controllers, so there's a common way for the control loop to drive an action. Scaling is an important blueprint. There's a set of enhancements to sort of continually improve this. HPA is hardware platform awareness. So the idea is the VNF describes the requirements it has, for example, huge pages or whatever, and then ONAP matches up that VNF with the right cloud. So if the VNF requires huge pages, then don't put it in a cloud that doesn't have huge pages. So HPA has been in the works since the Beijing release, continuously being improved, and this release also has several improvements. Change management. Change management is a broad set of sort of use cases. It's, of course, for updates and upgrades, but you can also have other types of changes in network services and VNFs. So there's this again was first rolled out in Beijing. There's been continuous improvement. In this Dublin release, you can have model-driven change schedule optimization, traffic migration. So whenever you need to migrate traffic to do some upgrade or change to a VNF, user-defined workflows. So the service orchestrator has this concept of workflows, so you can have user-defined workflows now. PNF software upgrade we talked about with rollback. So some fairly important enhancements to change management. So that covers what's happening with blueprints. Dublin release interop and standards work. The Linux Foundation Networking Group, LFN, has a program called OVP. It's a open source community-led compliance and validation program. It initially was supporting just NFVI, so NFVI compliance and validation, but more recently, as of April, it has been expanded to include VNF interop against ONAP. So the idea is to test commercial VNFs with ONAP and give them a certification badge. Currently, it focuses on static testing. So it just checks the VNF packages, heat, and Tosca. And what you will see through the rest of the year is more validation tests will show up to check initial instantiation, deployment of the service, termination of the service, and over time, other lifecycle management steps and monitoring, et cetera, as well. So it's work in progress, and over time, you'll see the program getting stronger and stronger. Of course, the program is meant to cover generic requirements across operators, and it does not cover operator-specific requirements. So there's a new feature in Dublin to allow VSP, or vendor software product, compliance check to be added in SDC. So, for example, if an operator says, I have this specific type of a cloud, and I want to check that the flavors match them in the VNFs, then they can add a specific test to do that. So that's a pretty nice feature. Standards alignment. This is actually a very important point. And to be honest, I didn't fully appreciate this point until recently either. Standards are increasingly relying on open source projects to provide a reference implementation. So whenever standards want to work with an open source project that's a Mano or a Mano++ in the case of ONAP, ONAP is more and more showing up as the de facto software stack of choice. And that's very important because that starts the virtuous cycle where more standards start relying on ONAP. ONAP starts being the reference implementation for more standards, and that loop sort of continues. And this is, if you say what's the single biggest reason why an open source project such as ONAP might win out over proprietary, in my opinion, this is the reason. More so than eliminating vendor lock-in or um, any of those other reasons, I think, or faster velocity or et cetera, et cetera. I think this is the important point. So you're seeing ONAP work with multiple groups. I've listed only 4. There are actually more industry groups and standard bodies that are working with ONAP, but these are the most important 4. So the main one, of course, is ETSI. So ETSI, there are 2 industry standard groups or ISGs where ONAP is working. The NFV ISG, SOL 3, which is the interface between NFVO and an external SVNFM, is already supported. So VFC supports it in ONAP, and SO also supports an interface as of the Dublin release. SOL 1 and SOL 4, which are around package, VNF package, and a descriptor, VNF descriptor, and network service descriptors. And SOL 5, which is the northbound API alignment, is continuing, and you will see ONAP become more and more compliant to these standards with time. ONAP is also working with the ZSM, industry standard group, on end-to-end architecture and network slicing. The next one is TM Forum. There is, ONAP has been selected as the reference implementation for a new business operating system effort, and there is continuing alignment with northbound APIs. And this is an example. So when TM Forum said, oh, we need to create this business operating system, what's a reference stack we can use for Mano? They selected ONAP. So that's where this virtual cycle that I mentioned starts to occur. MEF, there's alignment with the LSO APIs on the northbound side and also east-west. So we talked about CCVPN and how there was peering between ONAP, and that was based on some of the MEF work. And then finally, 3GPP. There's numerous 3GPP standards that are relevant to 5G, as you can imagine, and they're being actively supported in the 5G blueprint. So they're around data collection. We talked about performance management, fault management, data collection. Those all are around 3GPP standards, network slicing, etc. Okay, now let's get into sort of the bits and bytes in terms of functional enhancements. There are design time enhancements and there are runtime enhancements. And actually, if you remember the architecture picture, the third piece is ONAP lifecycle management, and there are enhancements on that as well. So all 3 have new features. Design time, there's a new configuration design studio. It allows for model-driven configuration and lifecycle management of VNFs. So you can, there's a design component, and actually there's a runtime component as well. I've listed it around design time, but it has a runtime component as well. So it's a very easy way to create these templates with design time attributes, and they can be triggered at runtime with additional runtime parameters for sort of day 0, day 1, day 2 configuration and lifecycle management steps as well. The portal framework had internationalization and localization support in Dublin. So now ONAP GUI can be delivered in different languages, not just English. There's basic PNF validation in Dublin to perform static checks on PNF packages. And we talked about the operator-specific VNF compliance checks already. In terms of runtime enhancements, a big one in my view is the support for Kubernetes, Azure, and Starling X in multi-cloud. So there's support for more types of clouds than just OpenStack. And as we discussed, there's initial support for CNFs now, and CNFs can actually coexist with VNFs and PNFs. There's a reference virtual firewall blueprint where part of it is in VNFs and part of it is in CNF. So it's pretty interesting. There are numerous policy enhancements. We'll look at them in a little bit more. And that allows new policies and policy types to be created outside of a release cycle. In DCAE, there are new collectors, event processors, and analytics microservices. We'll look at them, and that essentially allows for a broader set of use cases to be supported with closed-loop automation. AppC and SDNC now support Open Daylight Fluorine, which is the latest release that offers improved WAN connectivity and greater stability. And DMAP includes Kafka 1.1.1 that can now support multi-site applications. And there are enhancements to both data router and message router. So DMAP can do both. It can be a router for data and for messages. So we're not going to look at all the projects. There's a slide deck on ONAP Wiki, which I will point you to, which has enhancements for every project that you can look through. I'll also point you to the release notes, so you can go through that. But we're going to pick just a handful of projects where there's been, in my view, sort of substantial activity. So DCAE, and it's an alphabetical order, so we start with DCAE. So DCAE, there's a new suite of microservices, collectors, event processors, and analytics. There's a REST-conf collector, so that's pretty important. There's event processors, there's a WES and universal mapper, there's a performance management mapper for the 5G blueprint, analytics and root cause analysis, there's a SON handler, heartbeat, there's a next generation of the thresholding TCA microservice. There's a common SDK that was rolled out, enhancements for security, logging, resilience. DCAE uses Cloudify as a controller to deploy DCAE components in the right cloud, in different clouds in the right places. So there's an enhancement to support the Helm Cloudify plugin, health check improvements, multi-site Kubernetes cluster deployment. We'll talk about it when we go to OOM. Policy handler enhancements to support the new policy lifecycle API. We'll look at that on the policy page. And blueprint generator tool to simplify deployment of artifact creations. Music is a project that allows a network service to have, for example, 5 nines of availability, while the underlying infrastructure or the cloud only has 3 nines of availability. And the way it's done is by splitting the service across 2 clouds or regions. And the service to help you do that is music. So music is now provided as a fully sharded scale-out common service. So ONAP sites can be added, components, replicas can be added as required for performance, ease of deployment and performance. There's also some foundational work for edge computing. As you can imagine, for edge computing, spreading an application across regions or clouds it's almost a given. And seed code for database clustering, so you can share the state across sites. Multicloud enhancements, we talked about this to some degree. There's continued enhancements to OpenStack, Starling X, Lenovo ThinkCloud, Azure, Kubernetes, Wind River, VMware Integrated OpenStack or BIO. And there's an SDC client to retrieve workload artifacts from SDC. And security improvements / footprint reduction. We'll talk about footprint reduction in a little bit more detail. OOM enhancements. OOM is the project that installs and manages the lifecycle of ONAP itself. So there's improved platform health monitoring. There's security by the sidecar container called Envoy. And that also helps with network policy. Started the migration from single shared database instance that will also reduce the footprint. So what this means is there are many, many databases in ONAP, and sometimes you wonder why different projects don't share the database if it's the same database. Why have two instances? So that work has started. So there's collapsing of databases going on in Dublin, and that'll keep going on through subsequent cycles. So this is a multi-release effort. And initial support for multi-site Kubernetes cluster. So this is very important, because if ONAP is only in one Kubernetes cluster, then the availability is limited by that cluster. So if you want a highly available ONAP deployment, you have to, again, spread it out. Same discussion we had with music. You have to spread it out across multiple clusters. And that initial support is there in Dublin. OOF enhancements. OOF is the optimization framework. And it provides things such as the homing service. So if ONAP needs to decide which cloud to put a specific VNF in, it talks to the OOF homing service. OOF also does other optimizations. In this release, there's optimizations for traffic distribution, and specifically around the homing feature. In the previous 5G blueprint in Casablanca, there was PCI optimization. So that optimization now includes this automated neighbor relations optimization as well. Policy, there are lots and lots of new enhancements. There are reliability enhancements. There's a new API. There's a new lifecycle API that supports onboarding of policy models and templates and the creation of raw policies from those. There's a policy administration point, a next gen, that allows PDP or policy deployment points to be grouped together. And for SACML, there's a second gen lightweight SACML PDP. So the policy engine supports policies in different languages, and SACML is used for very lightweight, simple policies. So you have a next gen engine for that. There's also Drools and Apex. Apex was introduced in Casablanca, and Drools is used for more complex policies. So if you want to know more, we really did a very quick overview. There's lots of other enhancements in ONAP. You can go to a slide deck that goes through every project. So all 29 or 30 projects in ONAP are covered in that deck, and that's the first one. And then, of course, you can go through the release notes in ONAP documentation, and that describes changes and enhancements project by project. So now let's talk about S3P, or non-functional enhancements. So what is S3P? So it's scalability, security, stability, and performance, but also manageability, resilience, usability, and documentation. So with every release, ONAP attempts to not just work on functional items, but also on non-functional or S3P. A number of important S3P items in ONAP: footprint reduction. We talked about database sharing in OOM, where lots of services have lots of databases, and why can't we start sharing them? We can, and that's the first version of that is available in Dublin. The use of lightweight Alpine Linux OS in containers is another way to reduce the footprint, and the early results are quite promising. For example, the policy services experienced a 49% reduction in footprint. OF and HAS service specifically saw 64% reduction. And then there are memory optimization. So why is this important, you might ask? Why are people trying to reduce the footprint? So this has been a constant criticism of ONAP, that ONAP is very bulky, it's very heavy, the footprint is large, it requires lots of vCPUs and memory to support it. And this is an effort to start slashing that, cutting that down. So this was the first installment of those efforts, and you will start to see a lot more footprint reduction moving into subsequent releases. Security has been another sort of criticism, and there's a variety of new things in Dublin, and the momentum around security is only increasing. So you will see a lot more work going into security moving forward. In Dublin itself, there was additional pen testing, security policies between containers, consolidation of common third-party components, which in turn increases vulnerability checking, secure communication between XNFs, so that was all in Dublin. And additional S3P features, variety of number of projects improved logging, stability improvements. The documentation continues to improve. I would encourage you to check that out at docs.onap.org. It's actually looking pretty good. Next steps. So we've covered everything we wanted to in today's webinar. So where can you go next? So first, look for future releases. The next release is El Alto, e-release. It's going to be in end of 2019. This is going to be a non-functional release only. There's, and I think that's amazing. That's a great step. That means the community is really serious about the S3P items we talked about. And El Alto is going to be an extremely high quality release, I believe, for those reasons. After that will be Frankfurt. And I think by Frankfurt, we will see a full realization of the 5G blueprint. So I think for that reason, it's quite important. And the one after that is Gwilyn. And I haven't put dates on Frankfurt and Gwilyn, except to say that it's 2020, because there's an effort to reduce the release cycle time. Right now, it's roughly 6 months. So let's see how that ends up. And let's see if we get into a short cycle after El Alto. A little bit of advertising about ARNA. Next, you can try out ONAP. So ONAP is too heavy to try out on your laptop. So you have two options. You can try it out on a server. If you have a server lying around, then feel free to go to sort of the docs.onap.org, and they'll tell you exactly how to install ONAP on a bare metal server. If you do not, then the other option is to try it out in the cloud. And we have a distribution, ARNA Networks ONAP distribution, Anno 2.0. It's based on Casablanca that you can try out on Google Cloud. So instead of taking you 2, 3, 4 weeks to try out ONAP, this will literally take you half a day. The Dublin one, of course, will come in the next few months. This was very quick. If you want to learn more about ONAP, then we have a free book, ONAP Demystified. It is an introductory book. So if you're a sort of a beginner on ONAP, it's great. If you're an advanced user, then this book is not for you. And if you want to learn even more about ONAP through a formal training, then you can go to our training page. You can request for private training, where an instructor will train you and your colleagues from your company on site. Or you can request for a public training, which means that if we have a training in your city, we'll let you know. No sort of commitments on either side. And with that, we come to the end of our presentation for today. I thank you all for listening. And now, if you wish, you can unmute and feel free to ask me any questions and in the few remaining minutes. All right. I don't think there are any questions. So thank you all and have a wonderful day. All right. Thanks. Bye-bye.